Assalamu alaikum. Good morning, everyone. Today we'll start a new chapter, which is air and water. In this chapter, you will learn about purification of the water, a chemical test and a physical test to show the presence of the water, and air pollutants and how we can minimize the effect of the air pollutant, and manufacture of ammonia by a Haber's process. So first, the chemical formula for water is H2O, in which each hydrogen form a single bond with oxygen, and so between hydrogen and oxygen there is a share of a pair of electron, a covalent bond form, and there are two unshared electrons, a pair of electrons on oxygen. So this is a structure of water, we also call H2O. If we want to test the presence of the water, chemical test to check the presence of the water, so what we can do, a chemical test, if you want to find whether the water is present. Number one, we can add anhydrous copper 2 sulfate. So this anhydrous copper 2 sulfate, originally it is white in color. But if water is present, it will change its color to blue. So anhydrous copper 2 sulfate, it is white in color, but if water is present, it will change its color to blue. So this confirms that the substance contains water. Also, there is also another chemical test. We can also add anhydrous cobalt chloride. So if we add anhydrous cobalt chloride, originally this anhydrous cobalt chloride is blue in color. If water is present, it will change its color to pink. So the blue color will change to pink with anhydrous cobalt chloride if water is present, and white color of copper sulfate, anhydrous copper sulfate, changes to blue if water is present. These are the chemical tests, but there is also a physical test to show that a water is pure. Which show that water is pure. So what we can do, we can check the boiling point. If it is pure, it will boil at 100 degree centigrade. If it's impure, will have a higher boiling point. But if it is a pure water, it will boil at 100 degrees centigrade. So there are two chemical tests to check the presence of the water: anhydrous copper sulfate or anhydrous cobalt chloride. A physical test or the boiling point, we can also check and identify whether a water is pure or impure. Is it clear, this part? Yeah, take the screenshot for this part. Then purification of the water. If we want to purify a water, we can use a water treatment plant for purification of the water. So the first stage of this purification is involving a screening. Screening, what is the purpose of the screening? The first stage. So what we do in a screening, the water is pumped in a screen tap, and it will stop the big particles, large particle, small particles still able to pass through, but large particles are completely stopped. But this is not the pure water. This is just the first stage. So to stop the large particles, we use, like, this is a net made up of metal, which does not allow the large particle to pass through. Fine insoluble particles are still able to pass through. So this, the second part, second stage, there are fine solid particle. Then what we do, we use a coagulant. Normally, we use iron sulfate or aluminum sulfate can also be used. What is the what it will do when we use a coagulant? This coagulant will make these fine particles stick together. So as these fine particles will stick together, what it will turn into? It will turn into large particle. So we use a coagulant. Normally iron 3 sulfate or aluminum sulfate can also be used. So which the fine particles, fine insoluble particle which does not dissolve, they mix with each other due to this coagulant and form a heavy particle. So a coagulant is added, a chemical to make a small suspended particle stick together. Like normally we can use iron sulfate or aluminum sulfate can also be used. So second stage, we add a coagulant. Then what we do, this third process is also known as aeration. The next air is blown through the bottom, and this is known as a floating tank. What it will make? It will make the coagulant particle float to the top, and which we can skimmed off. Like example, when fine particle join together, it will become heavy. Then we blow the air from the bottom. When we blow the air from the bottom, so these particles will come to the surface. As these particles come to the surface, what we can do, we can skimmed off. Like you can remove the layer of these insoluble particles. Then there's another filtration, which is also known as sand filtration. So what we do, the water which we obtain here in the filtration tank, we do a sand filtration. In a sand filtration, we will pass this water through different layers of sand particles. So when we pass this through different layer of sand particle, so the insoluble particles stick with the sand and the water is able to pass through. But this water may have some odor or smell or taste. So if we want to remove any smell or taste, so what we do, we pass over the red hot charcoal, which will remove any taste or the smell. And then a chlorine is added. What is the purpose of the chlorine? The purpose of the chlorine is to kill bacteria. And then fluoride is also because fluoride compound is added to some of the plant, which help in fight the tooth decay. So if the water does not have the fluoride ions, then that dissolved impurities may cause a tooth decay. So fluoride reduce that effect. And then this water is pumped to the storage reservoir, which can be ready to pump to the homes. So these are the stages which are involved for purification of water. First, we do a screening. Screening means we separate the large particles, like example, wooden sticks are there, insoluble solids are there present. Then we use coagulant so that the fine suspended particle clump together, join together. Then we do aeration, means below the air, which increase the purpose of this, it increases the amount of dissolved air present in it, and we can remove the coagulants by skim off from the surface. Then we use a sand filtration, and then we use charcoal to remove any smell or taste, adding a chlorine to kill bacteria, and then fluoride compounds normally to reduce the effect of to tooth decay. And then the water is pumped to the storage reservoir, where it is ready to pump for homes or domestic use. Is it clear? The purification of the water, the steps, stages involved in the purification. Any doubt? In step 4, what we do in step 4, basically what happened in a sand filtration, as we already filter, like in the first screening, there is a net through which we are passing the water. Which is the first stage. So the large particles are not able to pass through this net. Small particles are able to pass through, fine particles. And then we use a coagulant and we remove that. But still, maybe some very fine particles are there. So if very fine particles are there, what we can use a sand filtration. How sand filtration is effective? Because in a sand filtration, there are different layers of sand. So which block or which does not allow the water to, which does not allow the solid particle to flow through. So when we have a sand filtration, so we have different size of sand particles. Large particles initially, then small particles, the layer of small particles, and then the fine sand is there. So what is the advantage of this sand filtration? When we pass the water through it, water will find its space, the water can flow, but the solid particles, different size of solid particles will be stopped according to the size of the particle. Like if it is large particle, it will not be able to pass through the top layer. If it is like medium particle, it will not be able to pass through the second layer. And if it is very fine particle, it will not be able to pass through the bottom layer. And so we will have only water and the sand particles are being removed. Is it clear? Then the composition of the air. So what air contain? Air contains 79% nitrogen, 20 or 21% oxygen, and remaining other gases are there. And water vapors are variable, like different region to region, the amount of water vapor vary. Then what are the pollutants? So composition of air by volume. So we have nitrogen present in air. What is the percentage of nitrogen in air? Yeah, 78% nitrogen is there. What's the percentage of oxygen? Approximately 21%. Then we have other gases. Carbon dioxide is also there. 0.04%, that's right. And other inert gases are there, which have the remaining percentage. So major composition is 78% nitrogen and 21% oxygen is there. So if we want to separate these gases from each other, so the technique which we use fractional distillation. Of liquid air. So if you want to separate the gases from air, we use fraction distillation of the liquid air. But before carrying out the fraction distillation, we remove carbon dioxide and water vapors. The reason why we remove carbon dioxide, because the carbon dioxide, also known as a dry ice, the carbon dioxide sublimate, means it directly convert from gas to solid. So it does not form a liquid state. That's why it sublimates. So we cannot do fraction distillation of the solid. It's only for liquid. So that's why we have to remove carbon dioxide. And why we have to remove the water? Because the percentage of the water is variable. Place to place, the amount of the water vapors or water present in the atmosphere changes. That's why we have to remove that water as well. So how we remove water? So to remove the water, we use a drying agent. Drying agent means the chemical which has tendency to absorb the moisture, that's called a drying agent. So to remove water from water vapors, from air, we use drying agent. The drying agent will absorb the moisture. That's one thing. And the second one, to remove carbon dioxide, we bubble the air or pass the air through sodium hydroxide. So what happens when we bubble or pass the air through sodium hydroxide? Sodium hydroxide is an alkali, NaOH, and carbon dioxide is acidic oxide. How acidic oxide? Because a non-metal oxide. So non-metal oxide is reacting with an alkali. NaOH is an alkali where carbon dioxide is acidic. So acidic oxide reacting with alkali, this will form a salt. It forms sodium hydrogen carbonate, and this sodium hydrogen carbonate is a soluble salt. So it will form aqueous sodium hydrogen carbonate. So it will dissolve. So carbon dioxide, when we pass through sodium hydroxide, it will dissolve. And the water, we already use a drying agent to absorb the moisture from the water, from the air. So now what we have a dry air. Dry air means the air which does not contain any moisture. Is it clear till now? We are carrying out the fraction distillation of the air. We want to separate the gases which are present in the air. So before carrying out the fraction distillation of liquid air, we separate carbon dioxide and water vapor. Carbon dioxide, because it's sublimate, so that's why we are removing it from the air. And water vapors, because it is variable from different place to place, the amount of water vapor is not same or constant in air. That's why we are removing that as well. So now the air which we have is a dry air which does not contain carbon dioxide. Is it clear till now? Any doubt? Now what we will do, then we will the fraction distillation. But before carrying out a fraction distillation, we should have a liquid air. So first we pump the air and we remove carbon dioxide and water vapor. Already we discussed how we remove that. Then we compress the air and cool. When we compress the air and cool, so what it will do, it will convert this air in the gaseous into liquid state around minus 200 degrees centigrade. And liquid air is pale blue in color, light blue in color because of oxygen. So we blow the air, remove carbon dioxide and water vapors, then we compress the air and allow it to cool. And we repeat this process until the air is converted into liquid state. And around minus 200 degrees centigrade, because we are compressing and cooling it down. So around minus 200 degrees centigrade, the air will be in a liquid state. Then this is a fractionating column, but this time in a fractionating column, we do not supply direct heat energy, because outside, because the temperature of the liquid air is minus 200. So when it will absorb energy from the surrounding, it will become warm. And you can see a very cold air is there. So this is around minus 200 degrees centigrade. And these are the boiling points of different gases. You can see oxygen has a boiling point higher than nitrogen. And first air is liquefied around minus 200. You can see the temperature increases until the oxygen boil and rises to around, oxygen boiling point is minus 183, where nitrogen boiling point is minus 196. So what happened, as this is a very cold air, it is minus 200 degrees centigrade. Now it will absorb the energy from the surrounding. So when it will absorb the energy from the surrounding, so how the temperature variation occur? As we know, the nitrogen, the boiling point of nitrogen is minus 196, and oxygen boiling point is minus 183. And the boiling point the boiling point of oxygen is higher. How it is higher? Because in terms of number line, minus 183 is high temperature as compared to minus 196. So what happened, as this will absorb energy, so its temperature will increase. Temperature increase here, what is the meaning of temperature increase? Like the temperature is minus 200, then temperature will be minus 199, then minus 198, then minus 197, minus 196. So when the liquid air absorb energy, its temperature is increasing. So as its temperature is increasing, as we know, the nitrogen boiling temperature is minus 196 and oxygen boiling temperature is minus 183. And the air temperature of the liquid air is minus 200. So first the temperature is minus 200, then the temperature from minus 200, it will become minus 199. This is called increase in temperature, because minus 200 is a low temperature, then minus 199 is a higher temperature than minus 200. Then it will become minus 197, 198, then minus 197, then minus 196. So once it reached minus 196, what happened? As we know, that's a boiling temperature of nitrogen. So that's a boiling temperature of the nitrogen. So nitrogen will convert into gas and that nitrogen will escape. Same thing, then its temperature changes from minus 195, 4, 3, and so on until it will be a boiling point of the oxygen. And once it will be a boiling point of oxygen, oxygen will convert from liquid to gas, and we will collect the oxygen. Why different regions we are collecting this gas? Because they have different boiling point and as well as rate of diffusion as well. Is it clear? The fractional distillation of air. Any doubt in this? Any doubt in this part? Uh, Not all. The reason is that because why all of the gases are basically what we do, we want to separate them from each other, and they have different rate of diffusion and different densities. So when they are converted, for example, as they are converted from liquid to gaseous state, they have different rate of diffusion and different densities. So not all of them can rise to the same level. That's why we don't have one opening. Like, why not it was like this, that we should have only one opening? Why it was not like this, that only one opening, and when we have that certain temperature, we collect that gas? The reason is that because the different gases have different densities compared to the surrounding. So the rate at and rate of diffusion. So these factors does not allow all of the gases to rise to the same height. Because if the gas is lighter than air, it can rise to a greater height. If it is denser, it cannot rise to a greater height. So that's why we have different regions where we collect these gases. Direction of the arrow is opposing the other first part. So we have a compressed air, but not all of the air will convert into gas. So we again recycle and add that air again until all of the air convert into a liquid state. Why here oxygen, even you can see that boiling point of oxygen is minus 183, which is higher as compared to nitrogen. Nitrogen is minus 196. So I told you, these regions, the parts where we are collecting, is not because of their boiling point, it also because of their densities, capability to rise in the atmosphere. This is not according to the temperature value, this is according to their region where they can rise to a greater height, densities. Example, if there was a helium, even though it was having low boiling point, but it will rise to a greater height because it will have lower density. Then we have air pollutants. So first one, carbon dioxide. What is the source of carbon dioxide? It is a greenhouse gas, but plants are. But the thing is, the main source is combustion of the fossil fuel, burning of the fossil fuel. That's a source. What are the effects to the environment? It is a greenhouse gas. It can cause a global warming. Then we have carbon monoxide. The source of carbon monoxide is incomplete combustion of the fossil fuel. And what are the effects? The carbon monoxide, because it can diffuse much faster to the blood, and it reduces the tendency, because iron, as we discussed, carbon monoxide is a good reducing agent. So it has tendency to remove oxygen from the blood, and due to this effect, it can cause suffocation. Suffocation means it reduces the effect of hemoglobin to absorb oxygen. Then sulfur dioxide. Sulfur dioxide, the source. What is the source? It's also a combustion of sulfur containing fossil fuel. Because the fossil fuel also have some trace of a sulfur. And what it can cause, what is the effect? It can cause acid rain. And if affects the pH, or it lowered the pH of, cause acid rain, and lower the pH of the water, affect the marine life or aquatic life. Then oxides of nitrogen. These oxides of nitrogen, such as nitrogen monoxide or nitrogen dioxide, how it is produced? It is produced in the source is the car engine. It is produced inside the car engine, and how it is effective. This oxides of nitrogen, brown in color, so they reduce the tendency of does not allow the sunlight to pass through them, so which we also call photochemical smog. And acid rain, because photochemical smog is a combination of smoke and fog. Like the term smoke and fog, when we mix them together, what it will form? It will form smog. So because these oxides, nitrogen dioxide is brown in color, so when it mixed with water vapors, it will form a smog, which reduce the amount of sunlight enter the earth atmosphere. Then sorry, lead compounds. What is the source of the lead compound in the atmosphere? Lead compounds are present due to leaded petrol. Because what happened? Petrol is a volatile liquid. Volatile liquid means it can easily convert into vapor. So to reduce its volatility so that it will not convert into vapor easily, lead is added. Now they are not using lead because it is harmful, but before it was used. So in these leaded petrols, what happened when a petrol is burned, the lead the lead is, because it's not reacting, it's just only to reduce the volatility of the petrol. So when it is released into the atmosphere and we inhale or take in, so it can cause it can affect the nervous system and damage the brain. The lead, originally lead is not present in a petrol. It's lead is, we are adding the lead in the petrol. And why we are adding a lead in a petrol? Because the petrols are volatile liquid. Volatile liquid means they can easily convert into it can easily convert into vapor. So to reduce this effect, that it will not easily convert into vapor, we are adding a lead. And when we burn the petrol, the lead is not burned, so lead is released in the exhaust vapors, and which can damage the brain as a person inhale those vapors. Then another pollutant, that's methane. The source, it's the livestock. In the atmosphere, we have anaerobic decomposition of organic waste. Landfills and natural gas. And what is the effect? Methane can also cause a global warming. It's also a greenhouse gas. Its effect to the atmosphere is 10 times more as compared to carbon dioxide. So it's a greenhouse gas which can cause global warming. So these are some atmospheric pollutants, air pollutants. Carbon monoxide is also produced in the car engine as well. That's a source. And methane, the formula for methane is CH4. Carbon dioxide is CO2. Carbon monoxide is CO. Sulfur dioxide is SO2. Oxides of nitrogen, NO. And lead is there, Pb. Now, what happened in the car engine? Inside the car engine, what we have, we use a fuel petrol, which is a hydrocarbon. Hydrocarbon means it contains carbon and hydrogen. So how a car engine is working? So the car engine take air from outside and it take the fuel which is already in the tank, and when there's a reaction between, this is a fuel, the hydrocarbon means it contains carbon and hydrogen, we call that as hydrocarbon. So in the air, oxygen is there and it produces spark in the engine. So when it produces a spark, basically the reaction is a combustion of the fossil fuel release energy from, or converted the chemical energy into heat energy, which we can use to move the engine parts. But what happened? It's not like a simple process, because the temperature of the engine is high. So nitrogen and oxygen which are present in the air can react with each other and form oxides of nitrogen, and they can escape to the atmosphere. Same thing, because the fuel is a hydrocarbon. Hydrocarbon means it contains carbon and hydrogen. So maybe the fuel does not burn completely or limited supply of oxygen. So due to limited supply of oxygen, we will have unburned hydrocarbon and we have carbon monoxide. So due to incomplete combustion, unburned hydrocarbons and carbon monoxide, and oxides of nitrogen are produced due to high temperature, and they're harmful to the atmosphere. As we discussed, what is the effect of oxides of nitrogen? It can cause acid rain or photochemical smog. And what is the effect of carbon monoxide? It can cause incomplete combustion. It is produced by incomplete combustion. What is the effect? It can cause suffocation. So these are the two harmful gases which are released. So we cannot allow these gases to escape to the atmosphere. So to overcome this, what we do, in after the engine, there's another device which is connected to the exhaust gases, and we call that as catalytical converter. So after the engine, the exhaust gases will enter the catalytical converter, and from catalytical converter they will go out. But what is the advantage of this catalytical converter? This catalytical converter, it will change these gases into less harmful gases. Like carbon monoxide and oxides of nitrogen are harmful. So the catalytical converter convert these gases into less harmful gases. So example, as you can see, this is how actually the catalytical converter is there. The car catalytical converter. So what are the gases coming from inside from the engine to this catalytical converter? Hydrocarbon, unburned hydrocarbon, carbon monoxide, and oxides of nitrogen. What it will do, it will convert them into less harmful, such as water, carbon dioxide, and nitrogen. And how it is done? So it is having two type of catalysts. One is called oxidation catalyst. Another one is reduction catalyst. So first, what happened? The reduction catalyst means the catalyst which speed up the reaction and help in removal of the oxygen. We call that as a reduction catalyst. So reduction catalyst uses platinum and rhodium to help reduce the oxide of nitrogen and ripping the nitrogen atom out of the molecule and freeing the oxygen. So you can see the first stage, what they do, if you have oxides of nitrogen, the oxidation catalysts form nitrogen and oxygen gas. So oxygen is removed. When oxygen is removed, removal of oxygen is called reduction. And we use catalyst here to speed up the reaction. So we call that as reduction catalyst. So nitrogen oxide is converted into less harmful nitrogen gas. And then we have oxidation catalyst. Oxidation catalyst, what it will do? It will add oxygen or provide oxygen and speed up the reaction. So carbon monoxide, oxygen is added to it, so it will form carbon dioxide. So carbon dioxide is harmful, but compared to carbon monoxide, it is less harmful. And what is the overall equation for this reaction? That's oxides of nitrogen and carbon monoxide are converted into carbon dioxide and nitrogen gas, which are less harmful as compared to oxides of nitrogen and carbon monoxide. Is it clear? The catalytical converter, the car catalytical converter. So this catalytical converter is in the exhaust fumes, which convert them into less harmful substance before it is released to the atmosphere. So basically, what happened? Oxides of nitrogen converted into nitrogen and oxygen, and carbon monoxide is oxidized to carbon dioxide. And when we write a balance like full equation, what overall equation what happens? So overall what happened, like oxide of nitrogen react with carbon monoxide, it will lose oxygen, this will gain, so it will form nitrogen gas and carbon dioxide. Is it clear? The catalytical converter. Any doubt in this? Now some questions related to air and water. What's the right answer for the first one? Question 1. So look, in this atmosphere, carbon dioxide is 4%. So on Earth, we have only 0.04%. Nitrogen is 78% on Earth, and oxygen is 21%. The question is, which gases are present in higher percentage than on Earth? So carbon dioxide is higher and oxygen is also higher. So A is the right answer. Question 2. Many car exhaust systems contain a catalytical converter. Which change does not occur in a catalytical converter? So A is the right answer. Carbon dioxide does not convert into carbon. This happened, carbon monoxide to carbon dioxide, oxides of nitrogen also convert into nitrogen gas. Unburned hydrocarbon give carbon dioxide and water. A is the one which does not occur. Question 5. The gases coming from the car engine contain oxides of nitrogen. How are these oxides formed? C is the right answer. Nitrogen react with oxygen. That's why oxides of nitrogen are formed. Question 7. What's the answer for question 7? Yeah, that's right. Oxidation means addition of oxygen. So which gas is removed by oxidation? Carbon monoxide. Because the carbon monoxide reacted with oxygen form carbon. Carbon dioxide is not removed, nitrogen oxide is reduced. Question 9. The diagram shows some uses of the water in home. For which use it is important for water to have been treated? A is the right answer. We only for cooking we need a treated water. Question 10. I want participation from everyone. What's the right answer? D is the right. Because oxides of nitrogen are removed from exhaust by reduction, because NO is removed and converted into nitrogen gas. Question 11. Photosynthesis and respiration are important natural processes. Which statement is correct? For question 11. So photosynthesis produce glucose and oxygen. That's true. Glucose react with water to form oxygen during respiration. No, it's not with oxygen. It's with water. With what? It shouldn't. Glucose react with water, but it should be with oxygen. Carbon dioxide is removed by respiration. No, it is increases the amount. Carbon dioxide is formed by reaction of glucose with water. During photosynthesis, the glucose is not reacting with its water. Water is there reacting with carbon dioxide. Question 12. What's the answer for question 12? Question 12. What's the right answer? Carbon cycle includes process of combustion, photosynthesis, respiration. Which rows show how each process change the amount of carbon dioxide? So correct answer for this one is C. Combustion increases, photosynthesis decrease, and respiration also increase. Air is a mixture of gases. Which gas is present in the largest amount? Yeah, that's right. Nitrogen. Question 15. Which information about the carbon dioxide and methane is correct? So both are greenhouse gases formed by vegetation or decomposition. It should be methane, not carbon dioxide. Both are greenhouse, that's correct. Present in unpolluted air, carbon dioxide is there, methane is not there. Produced during respiration, carbon dioxide is produced during respiration. Question 22. The flow chart shows a stage in the treatment of a river water to produce drinking water. What occur at stage X and Y? So at X, first we filtration and then chlorination to kill the bacteria. So these are the some questions related to air and water. Still the topic is not finished. Next time we'll complete this chapter and discuss the manufacture of ammonia by a Haber's process. Any doubt related to the class today? Okay, so I'll end the session and share the recording with you.